record ko pala.
Got it. Okay. Okay, so we have this triangle ABC. The length of BC is 20. And then the incircle trisects the median AD, which means it divides that median into 3 pieces, which are equal in length, which is x, so x. And then find the area of the triangle ABC. So one way to do this is to figure out the 3 sides, so that we could use Huron's formula, because we already have one side, which is 20. And then we were easily able to figure out that ACD is an isosceles triangle. So AC is also 10, just like CD. CD is 10, like BD, because AD is the median. Okay. So, yun ang nakalagay doon sa DE equals AF, and they are both equal to, I suppose what you really meant here. Yeah, I have not yet connected that. All right. All right. So this should be squared. Squared. So D equals AF equals X times the square root of 2. And then CF equals CE, so that means AC equals CB equals 10. Okie dokie. It's easy enough. Now, AF equals to AG, so that's X squared of 2. So now it's just an issue of figuring out the exact length of AB, and then because DE is X squared of 2 and this is 10, so that makes this 10 plus X squared of 2 BG, which is equal to BE. So that makes the length of AB equal to here, okay, 10 plus 2x the square root of 2. Now, to be able to figure out the actual area, we need to figure out the value of x. Okay, and that's where we use the fact that AD is a median whose length is represented by 3x, because there's actually a way of relating the length of the median with any of the with the sides. So there's a general formula, M sub A equals. I think did we go through the proof of this? I think we did, but do you remember?
No.
Oh, all right, so let's justify why is the length of the median to the side with length A equal to that formula. The reason behind is the law of cosines.
Because it looks nga po like the law of cosines.
Ano yan?
It looks like the law of cosines.
So in fact, it doesn't even have to be for a median. Let's say you have, this is B, and then this is C, and then this is just any segment dividing the opposite side in 2 lengths, M and N. A Sevian, and then this is, let's say, I'm thinking of a letter. For now, let's call it K. And then if that happens to be a median, M should be equal to N. All right, but let's try to figure things out in general. If we call this theta, then this other angle is going to be 180 degrees minus theta. And then from the left triangle, c squared equals m squared plus k squared minus 2mk cosine theta. Love cosines, right? And then on the right side, b squared is equal to n squared plus k squared. And then it should be minus 2nk multiplied by the cosine of 180 degrees minus theta. But how else can we rewrite this cosine?
Cosine 180 ano to pag cosine subtraction formula?
Okay, yes, but what is cosine of 180 degrees minus theta? I know you can use the cosine subtraction formula, but hopefully this is one of the things that you will get so used to that the next time you see it, it comes automatically. But it takes time and practice, so if it doesn't ring any bells yet, so can you try to think about cosine of 180 degrees minus theta through whatever method you can think of?
Okay. Cosine cosine theta minus sin theta. Ay, plus sin theta.
What is cosine of 180 degrees minus theta?
Oops. Cosine theta po. I forgot.
Not exactly. I'm trying to access the scroll bar.
Wait lang po. There's an angle and then 180 minus that. Negative cosine theta.
Negative cosine theta. That's it. Cosine 180 degrees.
When in doubt po, make a graph.
Okay, all right. Pwedeng ganon. You can think it in terms of, cosine 180 sine, cosine theta plus sine 180 degrees sine theta. This is 0. This is -1. So therefore, negative cosine theta. But for me, if you can remember the circular definition of these trigonometric functions, if this is theta, let's say it's an acute angle, then 180 degrees minus theta would be actually the supplement, the rest of the first quadrant and the second quadrant that we see. But if we're going to draw 180 degrees minus theta in standard position, meaning starting from the positive x-axis, this is how it's going to look like. Yeah, that's what 180 degrees minus theta is going to look like. The terminal point is going to be the cosine. So cosine of 180 degrees minus theta, and then the y-coordinate sine of 180 degrees minus theta. And then for the terminal point for theta, the coordinates are going to be cosine theta and then sine theta. Observe that the two terminal points are reflections of each other with respect to the y-axis. So that means they're going to be of the same altitude. The y-coordinates are the same. So sine of 180 degrees minus theta equals sine of theta. While their x-coordinates, while not equal, are negatives of each other. So that's why cosine of 180 degrees minus theta is equal to negative cosine of theta. So I hope that if we keep on repeating that argument, this is something that's with enough repetition, something that's going to come more naturally. Why it's cosine 180 degrees minus theta, the same as cosine of theta is negative. So rather than something we memorize, it helps if you can visualize, we understand why. Okay? Now going back, b squared equals m squared plus k squared plus 2nk cosine theta. Now, if you look at these two things, they look very similar to each other. They both have cosine theta expressions. The coefficients, say for the negative and positive symbols, are almost the same. They both have 2k, except ito merong m, ito merong n. What I'm going to do is, I'm going to eliminate cosine theta. I'm going to multiply the first by n. So nc squared equals m squared n plus nk squared minus 2m nk cosine theta. The latter, I'm going to multiply by mb squared equals mn squared plus mk squared plus 2m nk cosine theta. And then in case you're wondering, why did I multiply by n and m respectively? Do you see why?
Para ma-eliminate po yung 2M and D,
Yeah.
2M and D cosine theta.
Right, yes. Okay, so we have mb squared plus mc squared equals, then we have m squared n plus
This
m.
po, no? I think I remember this. Is this it's a variation for of Stewart's theorem or something? I think I saw this
Actually,
before.
this is Stewart's theorem. This is Stewart's theorem.
Before.
All right. So I suppose apparently we actually discussed this na pala. And then ito, mn, and then m plus n. M plus n is a. So, all right, let me rewrite this. mb squared plus nc squared equals amn plus nk squared plus mk squared. Now, if m equals n, meaning the CVN that we drew is median. If m equals n, then we will get on the left side n multiplied by b squared plus c squared. On the right side, a n squared. And then from the latter two terms, nk squared plus nk squared, so 2nk squared. We can divide all throughout by n. So b squared plus c squared equals a n minus 2k squared. And then k is the length of the median. So we will get k equals an minus b squared minus, wait, hold on. Why is it, why did this become, okay, that's supposed to be plus, sorry. Okay. So k is equal to b squared plus c squared minus an divided by 2 and then square root. And then we can rationalize, gawin natin inside, times 2 over 2. So the denominator is the square root of 4, so you get 1/2 outside. And then here, 2b squared plus 2c squared minus, is it consistent with your formula?
No, unfortunately, there's a square.
Unless I don't know, did I make, oh wait, hold on. N is, if n equals n, so then a equals 2n. Okay, so that means an is actually 2n squared. Or actually, hold on, maybe better. Wait, hold on. an equals the following: a, and then n is a over 2. So there you go, 1/2 a squared. Ayan. So now when we subtract, when we double am, that's just going to be a squared.
Nice.
All right, noise. Okay, so that's your formula. And going back, we get the following. Okay. I want to scroll back to the left again. Okay.
Press ano po, press shift while you're scrolling. Parang ano po
Press
siya.
ano yun? What's
Shift
that?
po. Shift.
Shift. Okay, sige nga. Try ko pag mamaya. Okay. Ito ngayon, pag nagmamouse over ako, nag-a-appear naman siya. Mamaya, okay? So remember, so AD is 3x, and then 1/2 twice 10 plus 2x squared of 220 squared plus twice 10 squared minus 20 squared. Okie dokie. So 3x 1/2. Then twice 100 plus. Joshua, shouldn't this be 40?
What? No!
All right, you're paying.
It's funny.
200, so minus 200. Anyway,
This is literally fun. This is literally for distraction.
boom. Anyway, we're gonna adjust. So you got 200 minus 200. Okay, at least you have magkakaso. But this ought to be 80 x squared of 2, and then 16x squared. So we have 6. So 6 x 20 squared equals 80 x squared of 2 plus 16x squared. 36 minus 16, yeah, 20x squared equals 80. So that actually means x is 4 square root of 2. So that makes the other side 4. So we get 4 times 2 times 2, 16 plus 10 is 16. So this is 26. So this is 26. So the semi-perimeter is 28. Tama, no? Kasi 18 to 26, we added 8. So that's divided by 2, so we need to add 4. So it's 28. That's semi-perimeter. So we get here 28. 28 minus 10. 28 minus 20. And then 28 minus 26. So we get 28, 18, and then 8, and then 2. 8. So this is 7 times 4. 18 is 9 times 2. 8 times 2 is 16.
The extreme lock.
Oh, wait, hold on. So 4 square root is 2. 9 square root is 3. 16 square root is 4. Then we have the square root of 14.
It's a victory.
All right. Makes you wonder. Okay. Anyway, yes, it's 24 square root of 14. You see the mistake.
It's a bittersweet moment when you at the end, but then you lost.
Yeah. Okay. Kasi nga, if it's a contest na, I think it would have hurt more. Parang on the first run, sige, bibigyan ng 10 points. But now, let's check the solution. And then you will see, oops, sorry, we're going to deduct from the perfect 10 points. Because the solution had a mistake. Okay, the
What about
other.
Tama, tapos now we're going to check the solution.
Sorry. All right. Oh, hey, you. Okay. I actually like the first smiley face. So try mo lang. Um. So find the length of arc AD. Anyway, I suppose you haven't really given this much thought yet, right? So I'd like you to think about this further. Okay, but well, siguro naman it's not giving away too much, but you'll have to start with figuring out PB. PB, diba? It's possible to figure out what PB is. Okay. And then once you have PB, look at PBC.
Abo, 45,
And
45.
then try to. Oh, okay, anyways, sige. Here, I think this is what circles P and Q tangent, radius 1, and then you have those tangent C's, find the length of AC. Let's just have a look at. I could go straight to your solution. Wait, pictures.
Sinisave niyo po lahat ng lahat po ng mga yung mga solutions.
I just got reminded that actually I don't have to. Well, I download them and then I insert them here, but apparently I could just copy them from Facebook yata,
Abo.
which I've never like. I just got reminded that you told me that, but yeah, copy image. Maybe next time. Okay, if I remember. Okay. So okay, AC equals CT. And then, so kasi 90 degrees yun. So AC squared plus AB squared equals TB plus CT squared. And then AB squared is the length of AB, one of the things given. Let me go back to the, okay. Each circle, actually that's the only length that's given, the radius. So 1, so that makes AB equal to 4 indeed. Okay. So 4, and then TB is, okay, TB plus CT, and then CT something that we are looking for. Right, for TB, you have, kasi from the point of view of a TB squared equals BR times BA, which is 2 times 4, 8. So yeah, TB is correct. It's 2 square root of 2. So that's what you put there. So yeah, AC squared plus 16 equals, and then TB is square root of that, just 8. And then, well, this ought to be double, of course, if you write it down. And then CT is, and then TB is 2 square root of 2. So okay, 4 square root of 2, and then CT is AC, right? The CT squared is AC squared. So tama naman nung eventually the equation you ended up writing, just the 2 there, then the AC squareds cancel. Okay, so AC remains in one place. 8 over 4 is 2, so AC is the square root of 2. Correct. Okay. Yes, AC is indeed the square root of 2. Nice. All right, Moise. Okay, so I see you already have access because you were in fact able to post something. You're looking great, Joshua. Okay,
So, portrait.
this is like the best I've seen you look. Okay. Okay. So let's talk a little bit more about circles. So I've been talking about the powerful point and also the radical axis of a circle. All right, and then some miscellaneous properties. Okay, so now any triangle can be inscribed in a circle, but not all quadrilaterals can be inscribed in a circle. All right. So the quadrilaterals that can be inscribed in a circle, so let's go back to cyclic quadrilaterals. We've already talked about cyclic quadrilaterals, but I'd like to go back to them because a lot more can be said about cyclic quadrilaterals. All right. In a cyclic quadrilateral, so some properties. What can you say about, how about, okay, Joshua, I tell you a quadrilateral is cyclic. Give me one property that's satisfied by that cyclic quadrilateral.
The opposite angles of the cyclic
Right.
quadrilateral.
Add up to 180 degrees. Okay, so kunwari you have A, B, C, D, angle A plus C add up to 180 degrees. Angles B and C add up to 180 degrees. Okay. And so therefore a rectangle is a cyclic quadrilateral, right? Because you got 90 degrees for the opposite pair of sides. A square is a rectangle, and so therefore a square is a cyclic quadrilateral. How about parallelograms?
Not always.
Not always. Okay.
Is
What?
it yung parallelogram? Then
Ano yan?
the other vertices cannot possibly be it. Cyclic.
So, extremely thin daw po yung parallelogram.
If a parallelogram is
It's very,
cyclic,
very thin. Abo.
what do you think should be true about such a parallelogram if it's cyclic? You're right. Not all parallelograms are cyclic, but for those which are actually cyclic,
They contain
what
the
do you
right
think?
angle.
Okay, so right angle. Kasi if you have ito, let's say if this is theta and this is 180 degrees minus theta, this would also be theta. So if this is cyclic, then that means theta plus theta should be 180 degrees, which means theta is equal to 90 degrees. So therefore, if a parallelogram is cyclic, then the only way that can happen is if it is a what?
Mm, or, the rectangle. Nasa,
Yeah.
nasa ko eh.
Okay,
Kasi dulo
kasi
ko.
90 degrees ng theta, it must be so, rectangle. So the only parallelogram which is cyclic is a rectangle. If a parallelogram is not a rectangle, then it is not cyclic. What about trapezoids? Can trapezoids be cyclic?
Mm, kung isosceles po sila, then they are surely cyclic. But again, it's still what the both. It still has to be some trapezoids.
Okay, so actually a trapezoid is cyclic if and only if it is isosceles.
What?
If and only if all right. Kasi suppose a trapezoid is cyclic. Okay. Suppose trapezoid A, B, C, D is cyclic. So we have this circle, and then you have A, B, C, D. since if A is theta, then that's going to make D 180 degrees minus theta. Okay, so let angle A be theta, then angle D equals 180 degrees minus theta. Because this is trapezoid, AB is parallel to CD. So let's assume it's AB and CD, which are parallel. AB is parallel to CD. Okay, but because this is cyclic, since it is cyclic, then A and C should add up to 180 degrees. So angle C should be 180 degrees minus A, which is 180 degrees minus theta. But then what we observe here is that angles D and C are equal. So the trapezoid is isosceles. And then on the other hand, suppose we have an isosceles trapezoid. You can work backwards because if you have an isosceles trapezoid, hindi ka na isusulat formally. So let's say this is alpha, and then this is alpha. Isosceles trapezoid. But because this and this are parallel, then if this is alpha, this must be 180 degrees minus alpha. But then what that forces is fine situation. These two opposite angles are supplementary. And that is enough to conclude that a circle must pass through all the four vertices. Because for the situation actually is ganito. If you have a cyclic quadrilateral, the opposite angles add up to 180 degrees. It's actually an if and only if situation. The converse is also true. If you have a pair of opposite angles adding up to 180 degrees, then the quadrilateral is cyclic. Okay. All right. So of course, if you have a question, so just let me know. But I'd just like to point out if trapezoid ABCD is isosceles, it can be shown it is cyclic because a pair of opposite angles would add up to 180 degrees. Okay, so as far as specific polygons are concerned, how about a rhombus? Can a rhombus be cyclic?
No, unless it's a square.
Okay, so the only time a rhombus is going to be cyclic is if it's a square. Kasi parallelogram eh. Okay, a rhombus is a parallelogram. And so it must be a rectangle. So, but then the only rhombus, which is a rectangle, is a square. All right, so that's our conclusion. Now, have you heard of Ptolemy's theorem?
I know the name, but I see. Polymerase theorem. It exists, but I don't know for the proposition.
Okay, so Ptolemy's theorem is another property of cyclic quadrilaterals. And at least as far as computations are concerned, this is one of the more basic theorems. It goes this way.
Di ba po si Tolan yata po yung nag-ano po na nag-theorize po na the solar system is or the it orbits Earth? Di ba po siya yan?
I'm
Or
not
iba?
sure. I'm not sure. Kung ano nung... Wait, the solar system orbits or or Earth is the center of the solar system?
Ako.
Is,
Siya
is
yata po
that
yun.
could be? Parang ano eh, when you mentioned it, I could not posible. May mga iba sometimes na halimbawa, I don't think so. I think that's not true. Pero ito parang eh, but you know, I'm not sure. So Ptolemy's theorem goes like this. Suppose we have, oh, yikes, I didn't mean to. Let's use a different color. A, B, C, D. And then we have these two diagonals, BD and AC. Okay. Ptolemy's theorem says the following. If A, B, C, D is a cyclic quadrilateral, then AB times CD plus BC times AD equals AC times BD. Now, there's a lot of segments, and it would feel like something not easy to remember, but actually it is. Let's look at the first term, AB times CD. This would be the
Opposite side.
product opposite, ito, AB and CD. And then on the other hand, BC times AD would be the product naman. All right, so opposite. Natitira na lang AC and BD, which is the product of the two diagonals, AC times BD. So ito yun. Okay,
So the
so
sum
if
the sum of the products of the two opposite the four opposite side the of the two pairs of opposite sides
two pairs of opposite sides,
is equal to the product of the diagonals.
yes, yes, and this is something that's true if ABCD is a cyclic quadrilateral. Okay. Before we, so is this your first time to see this, or have you seen this before?
Nakakakita ko pa.
Nakita mo na before?
Hindi. Ngayon ko pa lang.
Ngayon lang. All right, all right. So, I remember the first time I encountered this, naisip ko, wow, parang may mga ano pa pala, may mga iba pa pala mga facts which are true about these geometric figures. And the nice thing about a property such as Ptolemy's theorem is it's actually rather simple. I mean, of course, if you're used to formulas, it's actually easy to remember. So if you're comfortable with formulas, madali lang siya tandaan. So I thought that was amazing. So before we look at a proof, so tingin muna tayo sa ilang applications, some examples of Ptolemy's theorem. Okay. Let P be any point on the circumference or on the circumcircle of equilateral triangle A, B, C. Okay, and then connect P to the vertices. Show that the longest of these three segments equals the sum of the other two. Okay, so let's draw the equilateral triangle ABC.
Bro,
Pwede na, mukha ng equilateral, no?
medyo po squat.
Medyo, natin, adjust natin with the circle. Okay.
para po siyang it's too large and it's too thin. It's too short and it's too fat.
Oo nga eh. So parang hindi siya mukhang hindi siya eh, yeah, parang babaan natin. Sige na, imagine na lang natin equilateral triangle siya, okay? So let P be any point on the circumference. So this is A, B, C. Let's suppose P is on arc AB, somewhere here. So connect P to the three vertices. So we have PA, and then PB, and then this is PC. So show that the longest of these three orange segments equals the sum of the lengths of the other two. Now, without loss of generality, suppose P is on arc AB. P could have been on arc AC or on arc BC. Definitely P is going to be in one of those. Suppose that P is there on arc AB. Suppose P is on arc AB. So it's clear which of the three orange segments is going to be the longest. It's going to be PC. Okay, because PA to PB, you're still contained within that particular circular sector or segment patawag dyan. Okay, so PC is the longest. So we want to show that PC is equal to PA plus PB. Now, Joshua, look at what we drew inside the circle. What do you see?
An equilateral triangle and then the parang I see something po eh.
So say you have 3 points A, B, C, but now it's not just 3 points. There are 4 points A, P, B, C.
Like quadrilateral and then
Yeah.
the PC is equal to PC is one diagonal and AB is another
AB is the
diagonal.
other diagonal. But yes, we have a cyclic quadrilateral. Then A, P, B, C is
Yes, kasi po
cyclic.
let's say BC is equal to 1. Then PAP times BC is equal to AC times AP plus AP times BC, which is AP, plus AC times PB, which is only PB, is equal to PC times AB, which is also 1.
Yeah. Or kahit we don't have to assume it's 1, but for scaling, actually that's valid. You could just represent the length of each side by x. So let AB equal to BC equals AC by x. So then we have PA times BC. So sila ng opposite, di ba? Plus PB times AC equals, and you're right, when you pointed out PC is one of the diagonals, PC times AB. But then PA, PB, and PC are each multiplied to BC, AC, and AB, the three lengths, which are all x. And so immediately PC plus PB equals, PA plus PB equals PC. So this fact is a direct consequence of Ptolemy's theorem. So ano pang mga kagilagilalas na consequence ang makukuha natin from Ptolemy's theorem? I have it. Okay. But of course, we're going to prove Ptolemy's theorem. Ipo-prove natin siya. Okay. Ito something basic. example.
Why were pyramids built as the square pyramids and not triangular pyramids?
Not triangular pyramids. I imagine maybe I wonder if squares are easier to construct than triangles.
I mean, they were able to construct triangles already po on the faces. So why don't they just construct a triangle so it will be more structurally integral, more structurally stable?
Oh, no, no, if the base is a triangle, di ba? Uh, I, uh, I mean, to the aliens. Okay, let's. I don't know. Of course, it's all just hypothesizing. But maybe they didn't know the structural soundness of triangles over quadrilaterals. But if they knew that, I wouldn't be surprised. They seem to be a rather ingenious bunch. But if they didn't know, ako I feel from the perspective of drawing, I feel it's easier to draw a square. Kasi um, it's easy to draw 90 degrees compared to 60 degrees. It's easier to parang magkakanto ka lang. So makakabuo ka ng right angles as opposed to 60 degrees. It's doable, but I imagine mas marami kang gagawin. So I don't know if they really wanted it to be so, baka kaya. Maybe it's not just geometric, maybe it's not just structural, maybe religious. Maybe there's something to be said about there being four vertices. You know, the four elements: fire, earth, water, and sabi ko na ba lahat? Again, I'm hypothesizing. It may not be just structural concerns, but perhaps also mystical religious concerns. But ultimately, I don't know. All right.
Mga
But
po kasi
wait, was that a rhetorical question or did you have an answer?
wala po. Wala po akong
All right.
answer.
All right.
Wala, yung
Sorry.
mga
But that's interesting.
if you look at the figure, it looks like a pyramid and then ABC is the base.
Oh, yeah. Oh, right. Parang tetrahedron, no? Parang
Opo.
tetrahedron. Tapos pinong nasa taas. And then you're looking at it from above, from a certain
Pwede mo
angle.
po nasa baba. Isipin niyo po at the same
Baliktad.
time. But you can think of it at the same time po eh. Kaya ko po yun.
Yeah, triangle. So, sorry, what's that? Medyo nagano? At the same
Pwede rin
time?
po, pwede rin at the same time po, you can see P as above. And then ABC
Mm-hmm.
is the base. You're looking at from the ground.
Yes, precisely. Kasi naka-orange siya, so parang kumari three-dimensional to piece where you're right from above. Okay.
Opo.
Yeah, the triangle ABC. ABC equals 7, AC equals 8, and then BC is equal to 9. And then, so these are the three sides. Okay. Point D is on the circumcircle of triangle ABC. So that AD bisects angle A. Find the value of the ratio AD over CD. Okay, so we have a triangle where BC is the longest. So drawing the long triangle.
Imagine not using the line 2.
So BC, and then AC is 8, BC is 9. All right. AD bisects angle A.
Bro, alam ko po yung ginawa niyo po.
Ano?
Something ano po that has been cursed.
Okay, she should be left forever in a pyramid, never to be on earth, never to be resurrected. Right. So okay, there we are. And then AD is the bisector. So these two are congruent. Find the ratio of AD over CD. Ito no CD, which is green. And we have a circle on which are drawn 4 points. So here we see that ABDC is a cyclic quadrilateral. And then the segment with length 9 is a diagonal. 7 and 8 are the two sides. AD is another side. It's another diagonal whose value is not given, but well, I think we could do away with not knowing what it is because the problem's asking us for the ratio of just AD over CD, but not mentioned anywhere is BD. Anything special about BD in relation to any of the other segments? What do you think can be said?
I definitely do not see any cyclic quadrilateral anywhere po.
What? ABDC, cyclic quadrilateral?
Abo.
Okay, fine. You don't see any cyclic quadrilateral. Sure. And also you don't see any circle, right?
I don't even see anything on that.
But anyway, BD, or what's the consequence of the angle bisector there?
I mean, wait. Mm, wait. What was I going to say? I forgot what I was going to say. Mm,
So let's say you call this theta, and this is also, wait, let's make it orange. Theta in orange. What's the consequence of having those congruent angles theta?
hmm. Uh, Hanggang, I mean, they can be applied. Walang alam.
Keep in mind that we have a circle here and some of the angles are indicated. Each of those thetas is an inscribed angle.
Okay. So, BD has the same length as BC.
All right, yes, yes. So do you see that? The green segments have the same length. Okay. So BD has the same length as CD. Actually, it can be argued na kasi parehong theta yon. So that renders BD, the arcs BD and CD to be congruent. The arcs themselves are congruent, BD and CD, but since those arcs are congruent, their corresponding segments BD and CD are congruent. Pwede din naman, out of this theta, that makes this theta. And then out of the other theta, they're at angle A, that makes that theta. So we see BDC is an isosceles triangle, so BD is equal to CD. So sulat natin yun formally. Since AD bisects angle A, then BD equals CD. And then by Ptolemy's theorem, Ptolemy. let's see what we get out of that. AB multiplied to CD, it's opposite. And then from A, you have AC. The opposite is BD. The two diagonals are AD and BC. BC is 9 and AB is 7. AC is 8. BD and CD are the same. So this is also CD, which means on the left side, we have 7 CD plus 8 CD, 15 CD, and 9 AD. So it's straightforward. AD over CD is 15 over 9, which is 5/3. Right, so straightforward application of Ptolemy's theorem. I have other examples, other illustrations, but because we pride ourselves in appreciating the importance of proofs, it's high time we look at a proof of Ptolemy's theorem. Why is Ptolemy's theorem true?
POV po, a new theorem learned. About 5 seconds later. Let's
Oh,
prove. Dun, 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 dun.
yeah. All right. Okay. Proof of Ptolemy's theorem. I like the figure here. Oops.
No!
Okay. Not what I intended to do. All right.
If the boy has been exposed.
Okay. Hold on. Ito. Just gonna go around it. Ayan. Copy. And then
Someone has to be sabotaged.
no. All right. Proof. Ayun na. All right. Proof. Ayun na.
Petition for Microsoft to ban CTRLC in OneNote.
I think that's going to be disastrous for the economy if suddenly Microsoft disables Control C. That's going to have an impact on what countless operating systems and softwares around the world. Okay.
It will lead to
Yeah.
an economic recession.
Oh, nga, ganun na mangyayari. Oh, come on. Hold on. Okay, I'm going to close this.
You have been punished for your sins.
I know, right? But Joshua, it was all worth it. It was so worth it without my share screen. So we want to show, okay, Ptolemy's theorem. AB times CD plus AD times BC equals BD times AC. Okay. I'd like to call you. I'd like to draw your attention to. Well, there are many triangles that can be drawn here. One of which is the following. Okay. Maybe I'm gonna highlight this. Okay, maybe trying mas makapal. Ito. Okay. So let's have a look at A, B, D. Actually, I'm trying to remember the proof. Okay, pero hold on. Once I remember the proof, tuloy-tuloy na yan.
Kaya po it has been erased from your memory and ano po, in exchange for ano po, your ano war crime of committing ano CTRM.
Yeah, that's what happened. And, okay, yeah. So give me 2 minutes. 2 minutes to remember the proof.
In ano po, it has been labeled as a war crime in the Geneva Conventions revised.
Oh my gosh. All right. All right. Um, we're gonna look for similar triangles here. Okay. Now
Similar
uh,
triangles.
I wanted to undo the highlight. Okay. Parang mas nalito lang ako. Oh, okay. Got it. Because there are a lot of congruent angles here, right? So for example, itong angle na to, okay, these two are congruent, right?
Opo.
Because you have, well, yeah, you have those inscribed angles subtending the same arc BC. Now, meron tayo dito na wait, palitan ko to, sorry. Okay. Oh no, it's not exactly the same. Okay. Or just so it would be easier to see. Okay. Let me move D here. D. And then I'm gonna erase this D here. And then these two are the same angle. Okay. Now let me point out this green angle. Ito. So far, wala siyang kapareho. But here's what I'm gonna do. I'm gonna locate the point E here. Such that ABE will have the same green angle. Proof. Locate E on AC such that ABE equals angle DBC. So they are the two green angles. ABE equals DBC. Now, Joshua, do you now see two similar triangles?
No. I only see BAE and B something C.
Okay, BAE has a blue angle and a green angle. Do you see another triangle with the same blue angle and the same green?
BA intersection and something intersection DC.
Sorry, what's that?
BA intersection of diagonals and CD intersection of diagonals.
Oh, okay, okay. B again, say it again. Or
BA other point is intersection of diagonals and
oh, yeah,
CD
for now. So are you talking
diagonals.
about BAP?
Yes, about BAP and CDP. Also po, BAE and BCD.
Wait, hold on. Did they say BAP and CBP?
Opo. CDP. CD.
Wait,
Charlie
CDP
Delta.
and wait,
Charlie
CDP,
Delta.
CDP and
And BAP po. Bravo Alpha
B.
Papa.
Oh, Bravo Alpha Papa, BAP. I see they have. Ah, yes, you're right. You're right. You're right. Because they have the same blue angles. But okay, there's a reason that I located the green angles. So
Opo.
a triangle with the blue and the green angle.
Bravo Alpha Echo and Bravo Charlie
Ayun,
Delta.
Bravo Charlie Delta. Okay, but actually, okay, since okay, angle BAE equals angle BDC, Bravo Delta Charlie, then triangle, it will, may not be the same orientation. Pero sige, what was that? BAE, Bravo Alpha Echo. Is that what you said kanina? Okay.
Opo.
Bay, haha, similar to Bravo Delta Charlie. All right. Which means we can write down a proportion. Eraser, ay magpabura. Okay. Let's copy and then
POV.
delete.
POV po. POV. The eraser won't work.
Oo nga, ayaw. And then
Let's
ito.
literally cut out that portion po of the whiteboard.
It's still punishing me. Okay. So from here we get AB equals on the other side. So ito AB and then DB. Or observe that AB and DB appear in Ptolemy's theorem. Tapos, is there anything else kaya na nag-appear sa Ptolemy's theorem,
The other ones.
which we can gather from this similarity statement? So anong denominator kaya?
Uh, 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 mm, mm,
I mean,
mm,
which of these? CD, AD, BC, or AC?
AB over AC? Ah, yes.
The AB over taken from the first triangle. No left fraction. Let's take it from the first triangle, the left triangle, and then the right fraction. Let's take it from the right triangle.
Okay, so I think AB over AB over B. Hmm. Anyway, DB
Ganito,
over
CD.
DB
Can we get it from
DB
CD?
over DC over CD is equal to AB over I think AE about AE.
Okay. So if I wrote it as CD, so let me write it as EA. Okay. But let me write this as follows. AB times CD. Observe that that's the first term on the left. AB times CD. Ito yun, no? Ng AB times
Okay.
CD from this
So
first.
makakuha po natin AB times CD is equal to EA times BD. If we add the
Okay.
next one, the other one, it will become BE times, I don't know, it will become CD times BD. So if we add them, it will
Okay.
become BD times AC.
That's precisely what's gonna happen. Okay, that's precisely what's gonna happen. But let's okay, that's supported of things to come. But of course, let's justify. Anong similarity statement nung kailangan natin? So we want the involvement of this time AD. Tapos ito, tignan mo, sa nagalo ng AB times CD from the similarity. So numerator on the left side and then denominator on the other side so that we get to multiply them. So if we want something similar out of the second term, let's say AD is the numerator on the left, then BC must be on the right. Okay? Tapos, so target AD times BC. You said what we want to appear here is BD times, BD times what?
CE.
CE. So, gusto natin nung BD times CE, sila nung BD and then CE. So this gives us a clue anong triangle ang gusto natin tignan. Here ABD and here BEC. So let's specify, are they similar? ABD and BEC.
Draw an angle at ADB and ACB.
AC, okay. So ito, ibang color naman.
Yung ano pa yung gold?
Gold. Asan ba nung gold? Ito ba? Okay. Good. Okay. A, B, D, and B. All right, ito. Here.
Nice.
Noise. So B, E, C, and then A, B, D. That's shared. And then what else? What other angle is shared by ABD? And oh, ito here. Ito.
Alpha Bravo Delta and Charlie Bravo Echo.
All right. So you see where they equal now? Kasi they share the middle part, and then the green angles are congruent. So the angles marked in blue are congruent. Okay. So now onto the second part. Since angle ABE equals angle DBC, then angle, ano na magpapareho? Nung blue naman, this time, ABD equals EBC. Also, ng mga gold naman, BDA equals BCE. Therefore, triangle ABD is similar to triangle EBC. Tama ba ng orientation? ABD, from triangle ABD, that's vertex A to the blue angle vertex to the gold angle vertex, so ABD. As for EBC naman, it's E, then to the blue angle vertex B, and then to the gold angle vertex C. All right. Okay. So consequence, we do get AD on the left side, for the right side, EC. And then from the left, BD, corresponding denominator on the right, BC, from which we get AD times BC equals BD times EC. All right. And you did point this out earlier.
If we add them po, it will become the end of the world.
Yes. All right. So this is 1 and 2. And then the ones in gold, or is that orange, scratch, but we've already accounted for them here. So let's clean this up and erase them now.
Gold the blues.
Okay, so from 1 and 2, So we get AB times CD plus AD times BC equals BD multiplied to EA plus EC, but it's the same point E, and EA plus EC make up the other diagonal AC. So we have BD times AC. So yay, that's Ptolemy's theorem. And we were able to come up with this proof of Ptolemy's theorem by utilizing the congruent angles we were able to gather out of the inscribed angles subtending the same arc. Yay!
The
Okay.
theorem's called.
Tingin tayo sa iba pang examples ng Ptolemy's theorem. So this is, I think, a trippy example in regular heptagon example.
Oh no, heptagon. POV.
I
It's
know.
the first time it's the first time po I've encountered a geometric problem involving a heptagon.
I know, right? Let A, B, C, D, E, F, G be a regular heptagon. Show that the following property is true. 1 over AB.
Other than geometry po, have you ever seen any use po of any of a heptagon?
No. 1 over AC plus 1 over AE. Okay. So, okay, first things first, we need to draw it. Now, because this is a regular heptagon, we can inscribe this in a circle. Tapos, I understand as I draw it,
Construct a regular heptagon using ano po, all straight edge and
straight
compass.
edge na, and no. Okay, no, okay. So, try lang natin. 1, and then tatlo sa left, tatlo sa right.
Dapat po gawin na po as much as possible. Gawin na po, make it look like kaya ganyan nga po. Make it look like ano po, parang medyo medyo more than po an octagon, and para po gagawin niyo po octagon, tapos tanggalin niyo po yung baba. Tapos
Okay.
you lengthen the sides po so it will fit a heptagon.
Wag na, tapos na ako, andito na eh. Ayan. Tapos na ako eh. Okay. AB is one of the sides. So all the 7 sides are gonna have the same length as AB. AC is
It
not a
very much
side.
appears po that it very much appears apparent that DE is the same length as AB.
Hopefully so. It should, of course, this being a regular heptagon. AC is a diagonal. AD is another. Wait, AC and. Well, actually, AC and AD have the same length. Okay, because AC is a diagonal separating, or parang AC, two vertices separated by just one vertex between them. So of course, AC equals CE and equals AF. On the other hand, the third denominator AE, two vertices separated by two in between them, G and F. So that makes AE the same as CF, for example, the same as BE as well. Okay, so we have, and then, ano pa ba? How about, let's say, two vertices separated by 3 points between them. Kunwari, AD, but so you have vertex G, F, E on the right side, but AD are separated by two vertices B and C on the left side. So already accounted for. So actually AB, AC, and AE are representative of the 3 different lengths that we could gather here. Wala nang ibang length out of sides and diagonals. AB, AC, and AE. AB is the shortest, so naturally 1 over AB is the largest of the 3 fractions. So, interesting. that it's equal to 1 over AC plus 1 over AE, the sum of the reciprocals of the two other possible lengths. Okay, so as far as the diagonals are concerned, kumbaga lumalabas, there are only two possible lengths for the diagonals. So there's the short diagonal AC and the long diagonal AE. Okay, so let AB be S. And then AC be M. And then AE be F. So AC for the short diagonal, then AE for the long diagonal. And I suppose we want to use Ptolemy's theorem here. So we want a quadrilateral where the short and the long diagonal appear. Ito nung so ito, gather natin. Ito nung short diagonal, so that's M. Pero hey, AD should have the same length as AE, di ba?
Britain moment.
So this is also M, right?
Nice.
Okay. So note that.
I think it works out for the heptagon because there will be an even number of diagonals.
Or even, okay, even number of diagonals. I mean, well,
If it was a
hey,
pentagon naman po, it would be it would be too easy. So they made it the
okay, so
heptagon. So
maybe,
it will be harder than easy, but not easier than hard.
all right. So it could be, or we have a, well, I guess with other sites, kasi, if there are more sites, say more than 7, when you look at the different possible diagonal lengths, mas marami na. With a heptagon, dalawa lang ang possible diagonal lengths, M and N lang.
Pentagon, there will be different.
3 na, no? For pentagons, kaya ng dalawa pa rin.
No po.
Okay, so ABCD is cyclic. And then, ano ng mga side lengths? So this is S, S, S. Oh, but then for that, we also need another diagonal. This is M. Pero ito, what's the length of BD? Do you see it's also M? Agree? Yes? Are we on the same page? Okay. So note that AD equals A equals N and BD equals AC equals M as well. But then because ABCD is cyclic, then by Ptolemy's theorem,
Is there a term for such a trapezoid? It is triply isosceles.
it's isosceles eh. So yun, kasi AB equals CD.
Opo, it's isosceles, and the top one or the bottom one is the same as the sides. It's like triply isosceles. I mean, like isosceles.
I don't know. Oo nga, no? Kasi this time, you have 3 sides which are congruent to each other.
Opo, so may isosceles.
And there's no such term I'm aware of. Anyway,
No.
BC times AD, I know, sorry, plus AB times CD, sorry, you will go unnamed. And then AC multiplied to BD, BC is S, AD is N, AB is S, CD is S, AC equals M, BD equals M. All right. Huh. Okay, so what? Wait, hold on. Tama ba? Okay, BC. S times N. S times S. M times M. Para gusto natin palabasan, 1 over S equals 1 over M plus 1 over N. It doesn't make this statement incorrect, but maybe this is not the cyclic quadrilateral that we want.
Maybe the cyclic quadrilateral that we want was a more abnormal looking quadrilateral.
Oh, more abnormal looking. So ito, we tried A, B, C, D. How about A, B, C, E?
No! Bruh.
Yes.
POVIC po select. No!
Oh, yes. Okay. A, B, C, E. Try natin.
Actually, there are only two possible quadrilateral. There are only two possible types of quadrilaterals that can possibly exist in a heptagon.
In a
One,
regular heptagon, no? So sila lang
one
nung...
and the chromium chromium pen.
I guess, ito na dapat yun kung ganun. Alright. So, we have ito nung orange. So this is M. How about BE? That's a long diagonal. So that should be
Long.
N. And then CE is the length of a short diagonal. So that's M. And then AE is has the length of the long diagonal. So that's M. Okay. So let's use A, B, C, E instead. So AB and then CE plus AE times BC equals AC times BE. So I hope this works. AB is S, CE is M, AE is N, BC is S, AC is M, BE is
I already
N.
see
All
one.
right. And then next is
You
divide.
you cannot do anything or it will cause the economic turmoil of the world.
There, no. So we're gonna proceed. So divide by M and S, we have 1 over N plus 1 over M
Oh, it's
equals
real.
1
It's
over S.
real.
It's real, my friend. All right, which is what we want to prove. Okay. All right. All right. Hey, something interesting. What I'd like to present is a proof of Ptolemy's theorem. Okay. Interesting proof of Ptolemy's theorem. Okay. I mean, I've already shown you a proof, okay, but well, I find it interesting. So let me share it with you. What's the original figure? So
Proof ng Ptolemy's theorem it goes like this po. Since Ptolemy's theorem was proven before, then therefore it's true.
yes. All right, and then I trust the person who proved it, so I don't need to see the proof anymore. Proof by
Source.
authority.
Source. Can you give me a source? Source. It was revealed to me in a dream.
Okay, sure. How dare you dismiss my dream? Okay. So so label natin ng side. So let's call these A and B, C, D, and then this is E, and then F. So we want to show that AC plus BD equals EF. Okay. Good. Let's label some of the angles now. Of course, a lot of these angles are going to be the same. Let's call this a different color, so easier to keep track. Alpha. So this is alpha. And let's call this beta. So this is beta. Let's call this gamma. So this is gamma. And then I know you've been looking forward to this delta. So that's also going to be delta.
Yes.
Yes, right?
A token of the year of the year of 200. 2020.
Okay, sure. Okay, let me take, see, at the point of view of hmm, all right. So it's not gonna be an so look at A, B, D. Okay. So some of the angles are gamma and then beta and then alpha plus delta. Now instead of drawing ABD, I'm gonna draw a scaled version. So something similar. And then so for ABD, the lengths are, wait, hold on, sorry. Ito nung E, so ito dapat F to dapat. The other diagonal, this is F. So okay, triangle with lengths ADF. Lalakihan ko, I'm gonna multiply the sides by C. So ito na siya ngayon. Okay. Okay, ito alpha plus delta, and then this is gamma, and then this is beta. Okay? Pero ang lengths instead of ADF, AC, DC, and CF. All right? Okay. Next. Ano naman ang next na i-drawing ko? AC,
Yung
and
next na
then
drawing na po is a triangle.
another triangle. Okay, I'm gonna draw another triangle naman. I'm gonna get ito. This time though, gusto kong tignan mo. Um, hold on. Okay, I'm trying to recall. Hindi ko dapat sinulat ko sa scratch. Ito, this time, BDC. Okay, ano angles niya? Beta plus gamma, alpha, and then delta. Okay, yun ang angles niya. Okay, but where do I want to draw that? Hold on. Okay, ito. I'm gonna draw. Okay. Ng pen. Okay, ng pen. All right. Okay. All right. Okay. So nung CBD, okay, so di ba ang angles niya alpha, delta, and ito ng alpha, delta, and then beta plus gamma. Okay. So ang sides are F, B, and C. But this time, larger triangle where the three sides B, F, and C are multiplied by D. Okay. So itong B na to, ito nung connecting delta and then beta plus gamma, ito nung delta and then beta plus gamma. So B multiplied by D. Okay. Tapos nung other dimension, okay, itong C, connecting the alpha and then beta plus gamma. So ito nung wait,
Oh no.
wait, hold on. Sorry. Okay, ito pa, sorry. Kamali. Okay. Ito, sorry. Gamma, and then ito nung alpha. Okay. So C, so multiplied by D, C, D. Tapos nung other naman, F connecting the angles alpha and delta. So ito yan, alpha and delta. F multiplied by D. So this is FD. Okay. Tapos, I meant to draw this so that itong two triangles na to, okay, so itong side na to and this side are collinear 180 degrees. By the way, from the original figure with the circle, what can be said about alpha plus beta plus gamma plus delta?
It is equal to some number, which
Oh,
is
equal to some
exactly
number.
180 degrees.
180 degrees. So do you see why now? Kasi ito, alpha, beta, gamma, delta. So they make up opposites. So 180 degrees. Tanggalin ko ng mga check marks. Papagulo. So 180 degrees.
It forms a parallelogram.
Which means, all right, so you see that? So which means ito, Joshua, no? If this is beta and this is delta, what should this be?
It's
Beta plus delta.
it's
So what should this be?
alpha plus gamma.
Alpha plus gamma. All right.
No,
Tapos,
it's not
observe that
real.
ito. alpha plus delta, beta plus gamma add up to 180 degrees. Which means, itong side na to,
It's parallel to the other.
and this side, they should be parallel. And furthermore, they have the same length. Which means this quadrilateral is in fact a
Parallelogram.
parallelogram. This
No!
quadrilateral is a parallelogram. Now let's fill in the missing angles. Ito, as you can see, this is
Beta. And then the other one's gamma.
all right, alpha. So if this is like stuck. So do you see this beta here?
Tapos, after the angles.
So this must be beta. And then if this is gamma, delta, then this must be delta. Do you see in the cyclic quadrilateral a triangle having those angles? Beta,
Beta, gamma, and alpha. Yes, it is a
ADC.
EDC.
Actually, no.
So they piece together.
If you look at ito, A, D, C, so delta, and then alpha plus gamma, and then beta. The sides are E, C, and then D.
I already see it. I already see it. It is scaled up by F. So the E will become multiplied by F.
Okay. And now do you see how Ptolemy's theorem follows?
No, I refuse to believe it.
Kasi, well, gets right? Ito. Kasi parallelogram, so that means this and this should have the same length.
They are not equal. I refuse to believe it. The Illuminati is the Illuminati is somehow controlled your mind point has told you to say that this proof is authentic.
This is an illusion. So anyway, yan, AC, colorful ng AC plus BD must be EF. Alright. So for something a little bit down to earth, okay, another consequence of Ptolemy's theorem is actually the Pythagorean theorem.
But
Okay.
no.
Oops, that's too much. Okay, remark. Because hey, sorry, again, still that's too much. Remark.
No.
Okay. Consider a rectangle whose side lengths are A and B.
No. I already see it. Just like that. I can see it already.
Okay, kita mo na. And then because this is cyclic, then we should be able to apply Ptolemy's theorem. Okay. So papangitan ko ng draw.
Does not even look like a circle.
How can Ptolemy's theorem be applicable here? This is by no means a circle. C, B, and A. So from Ptolemy's, alright, so A times A plus B times B equals C times, you can do it, Joshua. C times what?
C times D.
Okay, sure. C. So there we go. A squared plus B squared equals C squared.
Bro.
Alright, so it's easy consequence. Okay. Other problems from ito, syempre kasi susubukan kong mag-iwan sa'yo ng ano eh.
Polygon with 4 sides. And it's also a cyclic quadrilateral. A cyclic
Four sides lang?
quadrilateral with right angles. and then it's composed of a secondary, so a secondary artistic color, composed of blue and yellow.
Grabe naman, sobrang, ay, simple na. Yeah, alright. Sige, hanap po ng Ptolemy's theorem. Alright. Ito, example. In quadrilateral, so observe we're not saying anything about this quadrilateral. In quadrilateral, actually the problem says it's a convex quadrilateral, but is it cyclic? Nothing said about that. In convex quadrilateral, ABCD, AB equals 15, BC equals 7, CD equals 24, AD equals 20, and angle A equals 90 degrees. Find the length of AC. Okay, so I suppose when we draw this, let's start with angle A because it's a right angle. And then AB is 15. So let's say this is B. AD is 20, so let's make it a little bit longer. So the only other missing vertex is C. BC is 7, and then CD is 24. So BC is quite short. And then CD is 24. Dapat pala iniwan ko to sa'yo eh. About, ipagawa ko na lang to sa'yo.
Why?
Why not? Gawin natin because our lesson is cyclic quadrilaterals. Ito, green. So there's a circle, and then there's a cyclic quadrilateral inside. Ha 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 ha. Okay, ayan.
Surprise.
Okay, cyclic quadrilateral. Ay, di ba bagay? Isn't it appropriate? Bagay na bagay, di ba? Alright.
The smiley's face, but it stares into your soul.
Okay, bagay na bagay. Sana hindi masyadong mahirap. Ito, since I'm here to be able to discuss it, a hexagon, o hexagon naman,
Hexagon, bro. May ano po, may kulang na lang po is pentagon.
oo, pentagon na lang, pero ito, hexagon. A hexagon has side lengths so clearly not regular. Okay, okay, so sige, so dito natin lagay kasi
Isipin niyo po, isipin niyo po yun yung smiley face.
okay, kasi I will solve this. I will solve this.
Literally.
Yeah. And narito pala,
Execution date. November 1.
oh, so hexagon has side lengths 2, 2, 7, 7, 11, and 11. Okay. And is inscribed in a circle. Just because you're given the 6 side lengths of a hexagon, it doesn't mean it's going to be cyclic. Alright, but apparently for this problem, you don't have to worry about that. It's already given. This can be inscribed in a circle, so this is a cyclic hexagon. Okay. So, question: find the diameter.
Idea. The hexagon is the hexagon when divided into two will form two cyclic quadrilaterals.
Divide the hexagon into two cyclic quadrilaterals. So what do you mean? Right, 2, 2, and then 7, 7, and then let's say 11 and 11. Okay, what do you mean divided into two cyclic quadrilaterals? Which ones?
I don't know. Basta whatever will work.
Okay. Actually, that's of course something that you can can consider. Except, um, 2, 2, 7, 7. So the lengths are given in this order. And let me try to draw. This is gonna be ugly.
Why is this? Why is it going to be ugly? Oh no! Oh, no, that's the circle.
Oh, sige, para hindi ugly. Okay, ayan.
And
There you go. Alright.
very it very much fits the circle.
Nga, no? Parang nandito pa lang sa vertex na to, swak na swak. Alright. I suppose I could change it a little bit. So, oh no. Okay. Side
It
lang
will be
ang gusto kong palitan.
minor spelling error.
Okay, so that's 2. Then that's 2. So ito nung verses. So it's somewhere here. Sige, modify that.
Ah.
So ito nung isang 11. So, 7, and then 7. All right. There's something going on here with regards to how you have of the side lengths 3 pairs. Okay. 2, and then 7, and then 11. So this is, I'm going to present the solution for the fact that it's, I guess, nice. But I remember seeing the solution for the first time. This is not something I was able to solve. So it took me a while to understand. But eventually I figured, I thought, it's cool, it's nice. So that's what I'd like to share with you. Ganito. I'm going to take those 6 sides, imagine them as 6 sticks, ng 6 sides. So as you go clockwise, 2, 2, 7, 7, 11, 11. I'm going to rearrange them as 2, 7, 11, 2, 7, 11. Okay. Rearrange the sides. 2, 7, 11, 2, 7, 11.
Very
Here's 2,
circle-looking block.
and then 7, and then 11. And then, wait, lagyan natin ng 11.
Cyclic quadrilateral if you draw between the end of the 2 and the 11. Also by symmetric along that axis that along that portion. So
Yes, yes, all right. So hold on, again, may symmetry, let's say from here to here.
yes, and then just divide that it divides it into two cyclic quadrilaterals, and thus you can find the diameter.
And furthermore, that blue segment is what?
Something the diameter.
It's the diameter. All right. So I guess first things first. Is it still a circle of the same size?
Yes, because I don't know. All right.
Okay. So I mean, it's I suppose sige, tanggapin natin same circle, but of course it can be argued. Kasi ganito. Um, think of ganito. Balik tayo dun sa original. Isipin mo ginawa natin. Kinuha natin itong side length. Tapos itong particular arc na to. Okay, so you have that orange piece.
You just rearrange the arcs po.
Yes, all right. So we rearrange the arcs. It's the same arc lengths altogether, fitting to come up with a circle. So in the end, we end up with a circle of the same size. So which means for the second circle that I drew, the diameter will be the same as the diameter from the left circle. So it suffices to figure out the diameter from the second circle kasi pareho lang naman. Okay. Okay. Note that the resulting circumcircle will have the same size, same radius, same diameter. So let's figure out the situation based on the second. Okay, and let's label mga sige A, B, C, D. Which is cyclic. So observe AD is a diameter. Let the length of AD be equal to D. So ABCD is cyclic. We have representations for the four sides, 2, 7, 11, and also D. But if we're going to use Ptolemy's theorem, we need to represent the diagonals AC and BD. If we don't have that, we really wouldn't be able to complete Ptolemy's theorem. Pero paano kaya yun? Let's try to find a way. Paano ng AC? Ano length ng AC? How can we represent the length of AC?
By
Sige. AD is not just any chord. AD is a diameter. So what does that make of the arc ABCD? A semicircle.
yes, so therefore AC alpha Charlie delta is a right angle.
Yes. Okay. So ACD is a right triangle. Hypotenuse AD is D. And so CD is 11. AC is one of the sides, but we can relate it to 11 and the hypotenuse. So AC squared equals 11 squared plus D squared, which means AC is, hold on, sorry. Okay, this is of course false. The diameter is the hypotenuse. Okay. So d squared equals AC squared plus 11 squared. So that means AC is the square root of d squared minus 121. Similarly, ano nung next na titignan natin? Let's look at ABD naman. ACD. ABD. ABD is a right triangle. So d squared equals AB. Wait, AB is 2. So 2 squared plus BD, yung other diagonal, square root of the other diagonal is BD squared. So that makes BD equal to the square root of D squared minus 4. Ayan, now we apply Ptolemy's theorem on ABCD. Okay. On ABCD, so we have AB times CD plus BC times AD equals AC times BD. Been trying to go back to blue ink. AB is 2, CD is 11, BC is 7, AD is D. AC is the square root of D squared minus 121. BD is the square root of D squared minus 4. Okay, I think no way out of this. To solve for D, we just need to square the left side. So we have 2 squared times 11 squared plus 7 squared times D squared plus double. So 2 times 11 times 7 times D equals, on the left side, D squared minus 121, D squared minus 4, which is D to the 4. Yikes. Minus 125 D squared plus 484. Nung sa left niya, ano to? Oh wait, this is ano din? 4 times 121. So A, 484 plus 49 D squared. And here we've got 4 times 7 is 28. 28 times 11 is 308. 308D. 484, mercifully canceling. 0 equals D to the 4 minus 125 plus 49 is 174 minus 308D. Fortunately, we can cancel out. So D, well, cubic, at least minus 174D minus 3.
Yun na po. POV, Cardano's formula.
No! First, we're not gonna Cardano here. Okay, of course not.
I mean, sa depressed cubic naman po eh.
But we hope that this has an easy way through.
We hope. Pero kung hindi po,
We
it'll be
hope.
the...
But this is from a contest, so should be. But at any rate, as you can see, it's enough. Or you can look at the figure. D should be greater than 11. Because 11 is just a 4, and then D is So we're gonna hope that ano ba ng mga factors ng 308? 308 is so divisible by 4. 7, 28. Actually, how do we get 308? 28 times 28. So this is 28 times 28. Actually, square shot, 28 times 28. So 7, but actually dito siya galing. Okay, 4 times 11 times 7. So one of the factors, then we're gonna hope that it's an integer, and then dapat larger than 11. So gusto natin, one of the factors is d minus. Ano kaya? And we just try it out now. Also, ito, kung titignan mo ng AC, wait, asan ng ito, parang multi-dimensional version ng, di ba in a triangle, sa triangle inequality, any two sides greater than the last side. So ito, D, this is 2, 7, and then 11. So likewise, 2 plus 7 plus 11 must be greater than D. So ano tong 2 plus 7 plus 11? 20. All right. So if we're going to find a root, so factor ng 308, look for something between 11 and 20. Ano ang mag-work? Try lang. Factor of 308 between 11 and 20. 11 times 2, 22, lalampas na. 7 times 2, 14. Baka pwede, no? Try natin synthetic division. 1, 0, negative 174, negative 308. Let's try 14. 1, 14, 14, 14. 14 times 14, 196. 196 minus 7, 422. And 22 times 14. Actually, ito yun, 308. Kasi we have 2 times 11 times 2 times 7. 22 times 14, 308. Yoo-hoo! All right, so d minus 14, and then d squared plus 14d plus 22. Now, the thing about d squared plus 14d plus 22, even if it's factorable, even if it has an integer root, negative na dapat. Or check mo lang nung ano. Anyway, you can show na itong d squared plus 14d plus 22. Ano ba discriminant nito? D squared 196 minus 4 times 22. Actually, positive pa rin naman. So, kaso nga lang, the roots are negative. Has no positive root. Okay? Kasi if you plug in a positive number to replace d in d squared plus 14d plus 22, there's no way that's going to be equal to 0. So if it has a real root, it should be negative. So this means d is equal to 14. So that's the only possibility. Yay! Okay. Isa lang nabigay ko sa'yo na problem, Joshua. So, next time we meet, I'd like to give one more result involving cyclic quadrilaterals. Parang ano siya, extension ng Heron's formula. Di ba Heron's formula, inaantag ko na Joshua. Okay lang. All right. Time to call it a night. All right. It's okay, Joshua. Pahinga ka na. All right.
Okay po.
Thanks for staying, Joshua. Okay, and Sir Jay. Sige, have a good evening. Bye.
Okay po. Bye-bye po.
Bye. Pahinga na. Seems like you've had a whole day. Bye-bye.
Bye-bye po.
Bye po. Good evening